Back to the QST YouTube channel. Today I'll be explaining chapter 3 course version for mechanics in grade 11. Let's start. The weight of an apple on Earth is 1 Newton. Do you expect its weight to be the same on the moon's surface? Of course not, because G is different on the moon. That's it. Number 2. A spring of natural length L is deformed by 3 forces, F1, F2 and F3 shown in the table below. Okay, look. For this one, there is another version of it in the exam, like where they use X, but now they want it like we have L, so which is the length. So what we're gonna do is the final length minus the initial length in absolute value, so we can find. Wait, let me make it. Okay. So what I'm gonna do is for F1 I'm gonna do absolute value of 0.9 L minus L, which is 0.1 L. And then here for 1.10, for 1.1 L I'm gonna do absolute value 1.1 L minus L is equal to 0.1 L as well. And then for the 1.2 I'm gonna do absolute value 1.2 L minus L is gonna give you 0.2 L. This means F1 and F2 are equal. These two are equal. And F3 is greater than both of them. What are the two types of forces? Field forces and contact forces, or action at a distance forces and contact forces. What are the properties of any force? The properties of the force are the magnitude, point of application, and direction. Number 4. Draw the free body diagram of a sledge moving down a very smooth inclined slope. Okay, so here is the sledge. We're gonna have normal perpendicular to the surface like this, and then weight downwards. We don't have friction because they said very smooth, which means no friction, and that's it. Two forces of magnitudes 20 and 50 newtons act at an angle of 37 degrees with each other as shown in the diagram below. Calculate the sum of these forces on the diagram and calculate the magnitude of the sum of these forces. Okay, look, first of all we're gonna need to project, right? So let's do it like this, and here we will make it like a right triangle. Here we have 37, here is 50. We need this blue side, right? What would we do? What would we use? We would use cosine. So over here would be 50 cosine 37. And then up here would be 50 sine, because now we would want this yellow, which would be opposite, which means 50 sine 37. 50 sine 37. Okay, now the sum of the forces. First we're gonna need to find, what they're asking for is the x and y components. So for the x component, we're gonna add 50 cosine 37 to 20. So we're gonna get 60i, because we did 50 cosine 37 plus 20, then plus we're just gonna do 50 sine 37 for the y component. 50 sine 37 is 30 plus 30j. Okay, so for the magnitude, we learned this with vectors. What we're gonna do is radical 60 squared plus 30 squared. Radical 60 squared plus 30 squared, which will give us 67.1. Okay, number 6. The free body diagram below shows two forces F1 and F2 of magnitudes 4 and 15. Respectively, find the magnitude of the resultant and indicate its direction. Okay, let's do the same thing again. We have two forces, and now we're gonna need to project them again. So over here, we would have F2, which is 15. So 15 cosine 37, I mean 53, my bad. 15 cosine 53. And up here we have 15 sine 53. I'll just call it S for a shortcut. I'm gonna add the question. Oh wait, no, never mind, it's already there. Okay. And as we know, F1 is 4, right? So now we're gonna need to find the net force on the x-axis. So basically, the x component of the resultant, which would be 15 cosine 53 minus 4 I plus, there is only one component, like there is only one force on the y-axis, which is 15 sine 53. Let me just get the answer for 15 cosine 53 minus 4, so 5i plus 15 sine 53 plus 12j. Okay, and now for the magnitude, what we're gonna do is radical 5 squared plus 12 squared is equal to 13. That's the magnitude. And now for the direction, we're gonna do what we used to do with vectors, tan inverse y over x. Y in this case is 12 because it has j next to it. So tan inverse 12 over 5, let me just calculate that. Tan inverse 12 over 5, which is also 67.4. What is up with this number, bro? Gonna erase this. Number 7. Consider the following forces acting on a particle. What is the magnitude of the x component of the net force? Okay, this isn't as bad as the other ones. Okay, I'll just graph it here. Why is it? They're asking in number 7 to find the magnitude of the net of the x component of the net force. Let me make it smaller. That's nice. Okay, wait. Okay, what is the magnitude of the x component? Look, so we have a force here, right? Two forces actually on the x-axis to the right. So can I make it like this? We have 6 cosine 53. Again, imagine it like a right triangle. Okay, and basically project it. And then here as well we have 12 cosine 53. I mean 12 cosine 37, sorry. And now we're gonna add 6 cosine 53 plus 12 cosine 37 minus 5. Six cosine 53 plus 12 cosine 37 minus 5, which will give us 8.2. 8.2. Right. What is the difference between inertial and non-inertial frames? Okay. Inertial frames of reference are frames of reference which are not accelerating with respect to the Earth. So let's say I have a book resting on a table, and that is just simply non-inertial. That's an inertial. Okay, a non-inertial is it is a frame of reference which accelerates with respect to the Earth. So, for example, if a jogger is running, like if someone's running, for example, that's a non-inertial frame of reference. Okay. Number 9. A particle of weight 10 is sliding at a constant speed down an inclined plane of elevation 25 degrees. Calculate the friction acting on the particle. Find the magnitude of the normal. Calculate the magnitude of the reaction. Okay. First, let's start with the free body diagram. Here we have 25. Here we have our particle. Let me make it smaller. Move it like this. Vertically downwards, we have our weight 10. Just put 10 here. And I'm gonna make the y and x axis across the planes, so we can make life easier. Normal is perpendicular to the plane like this. Here we have the y axis, and then since it's like sliding downwards, that means friction would be opposing the motion upwards. So friction will be, right? Friction will be like this. And these are all the forces we have. But we're gonna need to project the weight since it's not like parallel to the axes. So here we also have 25. So this means this would be 10 cosine 25. And this would be 10 sine 25. 10 sine 25. Okay. They want the normal. We can do sigma Fy, like all the forces acting on y is equal to 0. This is because like on y there is no change in acceleration. So we can do 10 cosine 25 is equal to the normal. Now we can just find it on the calculator. So basically what we're doing here is the forces up are equal to the forces down. 10 cosine 25 is 9.1. Normal is 9.1. So we have the normal. Now we can find the friction same way. Sigma Fx is equal to 0. The reason why it's equal to 0 is because it's moving at a constant speed. So 10 sine 25 is equal to the friction. Again, same thing, we're gonna get friction is 4.2 newtons. Okay, we're done with part C. Now part C, calculate the magnitude of the reaction by the surface on the particle. So for this, like all we need, the magnitude of the reaction will always be the magnitude of the resultant of normal and friction. So what we're gonna do is radical 9.1 squared plus 4.2 squared. Radical 9.1 squared plus 4.2 squared, which is 10 newtons. Number 10. Right. Okay. Three identical springs, each of spring constant K, are all attached in parallel to a box of mass M. The box remains in equilibrium. The acceleration of free fall is denoted G. What is the expression? Okay. Now let me get this with me. This. Okay. Let's draw the free body diagram. We have the weight, which is mg, and tension. Look, tension, as we know, is... Wait, no, not tension. There are three tensions because there are three springs. T is equal to K del Kx. That's okay. So, since it's in equilibrium, sigma Fy is equal to 0. 3T is equal to mg. And then we're gonna substitute T by Kx. So 3Kx is equal to mg. They want everything, like, they want us to isolate x. So what we're gonna get, we're gonna divide 3k on both sides. So we're gonna get x is equal to mg over 3k. Number 11. A car of mass 800 kilograms can decelerate from 20 meter per second to 0 meter per second in 40 seconds. Newton's second law is F is equal to ma. We have the mass. We just need to find the acceleration. To find the acceleration, we're gonna do V final minus V initial over time. So what we're gonna do is 0 minus 20 over 4, which will give us negative 5. So we have the mass. We're gonna do 800 times negative 5. It could be 5 or negative 5 depending on like whether they want the magnitude or the force itself. So 800 times negative 5 is equal to negative 4,000. Okay. Now for number 12, define inertia and relate it to the mass of an object. Inertia is basically the resistance of an object to move, in other words. Okay, and we're gonna relate it to the mass. We're gonna say the higher the mass, the higher the inertia. Number 13. This question is really easy. You may think it's tricky and whatever, but okay, here we go. Here they said the hanging mass is 4, like the weight is 4. The acceleration of this is 2. So 2 meter per second squared. Now look, since this force, or you can say tension in this case, is the same since it's hanging freely, so this is T as well. So this is T, meaning that T is 4. So this is also 4. So the force is 4. We just need the mass. So we're gonna do 4 is equal to ma. We have acceleration, we just need the mass, 2m. Mass is equal to 2 kg. Number 14. A person walking at a speed of 0.9 meter per second applies a force of 500 newtons on the ground. What is the magnitude of the force exerted by the ground on this person? Look, Newton's third law of motion states that for every action there is an equal and opposite reaction. So, let's say we have a force of A on B, right? Force of A on B. That is gonna be equal to the force of B on A. So that's what we have here. The man exerts a force on the ground, 500 newtons. The magnitude of the force by the ground on the person should also be 500 newtons. That's it. A rocket is propelled by hot gases pushed out of it. The graph shows how the force by the gases in the rocket varies per time. Plot the variation of the force exerted by the rocket. It's basically gonna be the reaction. It's gonna be like the same thing but opposite direction. So basically the same graph. Friction. 3 wooden boxes are placed on different floors and are pulled with horizontal constant forces F1, F2 and F3 respectively. All 3 boxes remain at rest but are on the brink of moving. The frictional forces on each box are F1, F2 and F3 respectively. Compare the coefficients of static friction. Okay, look, this is where the annoying thing comes in. We're basically gonna find the coefficient of friction. Okay, so look, in this question, they want us to basically rank the coefficients of friction. So first let's do the weight. Here they want it as G. Don't assume that it's 10 or 9.8. Then here we have normal, that's up, which should also be G because sigma Fy is equal to 0. The weight is equal to the normal. Okay, and then again we're gonna use sigma Fx is equal to 0. We're gonna get 10 is equal to the friction. So 10 is equal to mu G. So 10 over G is mu. Now we're gonna do the same thing for number 2. Here we have down W is equal to mg, so G is gonna be constant, so 3G. So up should also be 3G. And then this is 2, so this should be 2 as well. So 2 is equal to mu times 3G. So wait, this was 10 over G. This is 2 over 3G. Over 3G. Now let's move on to the last one. Again, down we have 2G, which means up we also have 2G. Again, it's an equilibrium, so this should be 5. So 5 is equal to mu times 2G. Mu is 2.5G. No, it's not 2.5G actually, it's 5 over 2G. 5 over 2G. Now let's make everything the same denominators so we can figure out which one's the same. So 5 over 2G. We can simply make everything 30g in the denominator. So here it would be 300 over 3g. $30g, sorry. Here it's gonna be 20 over 30g. And then here it's gonna be, wait, we're gonna multiply up and down by 15, so 5 times 75 over 30g. So this is the largest one, this is the second largest, this is the third largest. Number 17. Into what form of energy does friction convert the energy of motion? It's just thermal, just memorize. Two blocks are either connected by a string S1 by a string S2 as shown below, and the upper block is pulled upward by another string S1. The masses of the upper and lower blocks are respectively mass 1 equals to 200 grams and mass 2 is equals to 400 grams. String 2 between the blocks will break if the tension exceeds 5 newtons, and string S1 will break if tension exceeds 10 newton. Use G is equal to 10 meter per second square. First, let's do part A, since part B will take me another hour. It's gonna be nice. Anyway, let's start with the free body diagram of M1. M1. So here we have tension up, T1 to be specific. Then down here we're gonna have W1, and also we're gonna have T2. This is because of, what's it called again? Forgot how to say it, but this is because M2 is also pulling on, like, there is a string under M1 pulling M1 down, so which is why we have another force T2 down. And then meanwhile for M2 we just have weight 2 and T2. So for first we're gonna need to find T2 so we can find the tensions in S1 and S2. So for T2 we're gonna do sigma Fy is equal to 0. T2 is equal to the weight, to W2. So 0.4 times 10, which is 4, so T2 is 4. We're done. And then again sigma Fy equals to 0. T1 is equal to T2, which is 4, plus W1, which is 0.2 times 10, which is 2, which is 6 newtons. We'll be doing number 18b because it's gonna be taking a long time. Second of all, number 19 is like not included as well. If I'm not mistaken, number 19 is not included in the material for my periodic as I know of. So now I'm gonna be solving the last and final question. Wait, the material. Yeah, last question. An Atwood machine is made out of two blocks of masses 50 grams and 300 grams, connected by a light and inextensible string passing through the groove of a massless and frictionless pulley. The heavier block is placed on a smooth inclined plane at an angle of 37 degrees with the horizontal. Okay, so for this question, they're saying an Atwood machine is made of two blocks of masses 50 grams and 300 grams, connected by a light inextensible string passing through the groove of a massless, frictionless pulley. The heavier block is placed on a smooth inclined plane. But I don't care about this at this point. I'm just gonna solve it, and that's it. I give up. Why is it like this? Okay, zoom out, and let's do this again. So here we have weight, here we have normal, here we have tension. Let me just clear it. Here we have tension, and then we're gonna need to project. Here we would have W cosine 37. Here we have W sine 37. Here we have tension. Here we have normal. Let's start. Wait, no, not normal. We don't have normal here. We have weight. Okay, first we need to find tension, so we can substitute it. Weight 2 doesn't matter. I'm just gonna call it weight. So here, sigma Fy is equal to Ma, right? So tension minus the weight would be 0.05 times 9.8 minus 0.49 is equal to 0.05A. You take 0.49 to the other side, you get T is equal to 0.05 plus 0.49, and now we're gonna substitute it here as well. So again, W sine 37 minus tension is equal to M2A. M2 is 0.3A. Okay, so W sine 37, so 0.3 times 9.8 times sine 37, which is 1.8, and then we take 0.3A to the other side. 1.8 minus 0.3A is equal to tension, which is 0.05 plus 0.4A. You take 0.05 to the other side, so you get 1.85. Wait, no, not 1.85, 1.75 is equal to 0.7A. You divide 1.7 over 1.75 over 0.7, so 1.75 over 0.7 is equal to 2.5. Now to get the tension, you just substitute it in any equation. I'm gonna substitute it here. So 0.05 plus 0.4 times 2.5, tension would be 1.05. Thank you guys so much for watching this video. We wish you guys the best of luck in your exams. Thank you again. I appreciate you guys watching the videos and helping us and whatever, but thank you and goodbye.